In vector fifth unit, in vector integration, we have the last three units, that is vector integral theorems. The first one is Gauss divergence theorem, where this is the transformation between surface integral and volume integral. Already before we have done surface integral, volume integral. The combination of these two is called as a Gauss divergence theorem. That means already we have done these two. The combination of this one is called the Gauss divergence theorem. So here is the formula. F is equals to f1i plus f2j plus f3k. N is equals to cos alpha, cos beta, cos gamma k, where cos alpha, cos beta, cos gamma are the direction cosines of the n, where f dot n is equals to corresponding I, j, k elements multiplications, f1 cos alpha, f2 cos beta, f3 cos gamma. And div f, we know the formula div f, dou f1 by dou x, dou f2 by dou y, dou f3 by dou z. Now the formula is triple integration. Just now I said that is a combination of surface integral and volume integral. So triple integral dou f1 by dou x, dou f2 by dou y, dou f3 by dou z, dx dy dz is equals to surface integral f1 dy dz plus f2 dz dx plus f3 dx dy. Let me see a problem. Here we have compute integration of ax square plus by square plus cz square ds over the surface of the sphere. X square plus y square plus z square is equals to r square. Here r is equals to 1. That is a point we have to observe. So by divergence theorem we have, so this is the Gauss divergence theorem direct formula. Surface integral f dot n ds is equals to volume integral del dot f dv. So given f dot n, this is in the form of surface integral f dot n ds. So this is of f dot n. So let me take this one as pi. So pi is equals to x square plus y square plus z square minus 1. Now here we have to find the unit normal n. The unit normal formula n is equals to, here we have del pi by mod del pi. So first of all let me find del pi. So assume this one as pi. Normal vector to the surface is pi is del pi. Del pi, del is nothing but I dou by dou x plus j dou by dou y plus k dou by dou z. Pi is this one. Correspond with respect of x, y, z, partial differentiation, we got this one. Now the unit normal to find n is equals to del pi by mod del pi. So the value of this one is this one, because x square plus y square plus z square is equals to what? 1. Under root of 1 is 1. 2 to get cancelled, xi plus yj plus zk. F dot n, to find f dot n. So we don't have f, so we write as it is f dot n is, just now we find n is this one. But actually from the given problem f dot n is what? This one. So we have the f dot n is this one. So this is a combination of, already we have n, to write f as like this, ax square plus by square plus z square from the given. So already we find n, f dot n. So the f may be in the form of axi plus byj plus czk. In this way we find f. Now let me find del f. So f dot n is over. Now let me find del f. Del f is what? Del I dou f1 by dou x. Del dot f means dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. Dou f1 by dou x is a, dou f2 by dou y b, dou f3 by dou z, z derivative 1 into say is c. This is del dot f. Now hence by Gauss divergence theorem, surface integral f dot n ds is equals to volume integral del dot f dv. Volume integral, already we find del dot f is a plus b plus c dv, and a plus b plus c integration of dv, integration derivative get cancelled v. So here v is nothing but is the volume of the sphere of unit in radius. A plus b plus c of v is 4 pi by 3. So let me see another problem. By transforming into triple integral, evaluate this one, where S is a closed surface consisting of the cylinder x square plus y square equals to a square, and the circular discs z equals 0 and z equals to b are the limit points. So let me see here, f1 dx dy, f2 dz dx, and f3 dx dy. f1, f2, f3, and we have f1. So dou f1 by dou x, dou f2 by dou y, dou f3 by dou z. To find del dot f is div f is this one. Why we are finding this one? Because we have the Gauss divergence theorem formula is surface integral f dot n equals to volume integral del dot f dv. Del dot f we find it here. Now by Gauss divergence theorem, from the given just now I said this one is equals to this one, so this total one is equals to, we find the value of this one is 5x square. Now here we have to do the limit points. So already he has given in the question the circular disc as z equals 0 to b, so z is equals to 0 to b, and here y square equals to a square minus x square, y equals to plus or minus on the root, so y is equals to plus or minus on the root, and y equals to 0, and x limit points x square equals to a square, and x equals to plus or minus a, plus or minus here are the limit points. Now here the function dou f1 by dou x plus dou f3 by dou y plus dou f3 by dou z, we got 5x square. We substituted it here. So for phi right outside constant, x square is the even function. So for even function we can write this one as 2 into 2 into, so 2 into 2 into it becomes as 4, 4 into 5 is a 20. So after simplification we got this one. Now we are going to solve this one as in parametric equation. Here let me take x is equals to a cos theta and dx is equals to, in the simplification procedure we will get the value of this one. Next important theorem is Green's theorem, transformation between line integral and double integral. So whereas double integral comes under the surface integral, line integral already we have done. Line integral is what? Curve integral f dot dr. So let me see is that one. So here we have the statement of the here, and the formula is curl integral f dot dr. Just now I said that is in the form of f is m dx plus n dy. So that can be written as curl integral m dx plus n dy is equals to double integration of dou n by dou x minus dou m by dou y of dx dy. So this is the formula. So let me see a problem for this. Using Green's theorem, evaluate this one, where C is the closed curve of the region bounded by y is equals to x square and y square equals to x. From these two parabolas, here we are going to find the limit points of the x varies from, y varies from. So the given equation is in the form of curl integral of em dx plus en dy, where m is equals to n is equals to, from that we will get dou m by dou x, dou n by dou x, and dou m by dou y. So this is the procedure. So let me see the two parabolas from this one by intersecting point. So we solve by these two, we will get the limit points. The points, intersecting points are 0, 0 and 1, 1. So from that we will get a diagram, the two parabolas intersecting points. So this is the region that we have to find. So dou m by dou x, dou n by dou y, that one is equals to, both are equal, so minus will become 0 by Green's theorem. Now this one is equals to, just now I said x varies from 0 to 1. Here origin is 0, 0, x varies from 0 to 1, 0 to 1, and y varies from, we have to involve the curves. So y is equals to x square, y is equals to x square to y is equals to root x, and the value of this one, dou n by dou x minus dou n by dou y, already we got 0, 0 into something is 0. This is a problem. Now here we have to find the verification. So what is the verification? Let me see this one. That means we have to find the LHS value and RHS value if the both are equal or not. So the result comes under the verification part. Now here the Cartesian form of the, we know the formula of the Green's theorem, this one. With respect of these vertices we are going to draw a diagram. So this is the diagram with respect of 0, 0, 2, 0, 2, 2, 0, 2. So we have taken the assumption of the points 0, A, B, C. Now from the given question m is equals to n is equals to, we have to do dou n by dou x minus dou m by dou y. So this is the dou m by dou y. So we have done dou n by dou x, dou m by dou y. So just now I said that verification means Take LHS, find the value. Take RHS, find the value. First of all, evaluation of the LHS. Evaluation of this one. Let me see. To evaluate curve integral mdx plus en dy, now we have along OA, along AB, along BC, along CO. These 4 directions we have to find the value of this one. So along OA, the first one, along OA, we have the line on x-axis y equals 0, y equals to 0, so dy is equals to 0. Now integration of mdx plus n dy is equals to, when dy equals 0 and the x limit points, x varies from 0 to 2, x varies from 0 to 2. When dy equals 0, 0 into something is 0, y equals to 0, 0 something is 0, so only we will get integration of x square dx, integration of x square dx, and x limit points, x varies from 0 to 2, x varies from 0 to 2, and solving this one we will get 8/3. In the same way, along OA is over. Now let me do along AB and along BC and along CO, and addition of these all will comes under the part of evaluation of mdx plus n dy. Yes, along AB, x is equals to 2, dx is equals to 0. Again this one substituted here, simplify. Next, along BC, y is equals to 2, dy is equals to constant 0. When dy equals 0 and y is equals to 2, substitute here x square minus 8x, dx, and x varies from here 2 to 0, x varies from 2 to 0. You have to observe this. Similarly, along CO, after addition of all this comes under, just now I said evaluation of this one. So addition of these all, equation 1 2 3 4, we will get the value of 8. So LHS part is over. Now we have to find the RHS. RHS is what? It comes under the part of evaluation of this one. Now x ranges from 0 to 2 and y ranges from 0 to 2. X ranges from 0 to 2 and y ranges from 0 to 2. So in this one, so this one dou n by dou x is equals to x varies from y varies from. So by Green's theorem, dou n by dou x minus dou n by dou y substituted here, we will get the value of this one by observing the evaluation of both LHS and RHS. Therefore, hence the Green's theorem is verified. Next one, Stokes theorem. Here the Stokes theorem formula is curve integral f dot dr is equals to surface integral curl f dot n ds. Curl f means del cross f. Now let me see a problem for this. Verify Stokes theorem. F is equals to, over the upper half of the surface of the sphere, this one, bounded by the projection of the xy plane. Here you have to observe that xy plane. Now the boundary C of curve of the surface is a circle in xy plane. That is in xy plane only. He mentioned that actually it is a 3-dimensional, but he mentioned that xy plane, that means z is equals 0, so it will become x square plus y square is equals to 1, where z is equals to 0. Now this is a circle equation where r is equals to 1. So from here, by taking the parametric equations, x equals to r cos theta, y equals to r sin theta, here r is equals to 1, so x is equals to 1 into cos theta, r equals to 1 into sin theta. Theta varies from 0 to 2 pi, and dx is equals to minus sin theta d theta, dy equals to cos theta d theta. Curve integral f dot dr, f1 ds, f2 dy, f3 dz. So substituted here, theta varies from 0 to 2 pi, parametric equation x equals to cos theta, y equals to sin theta. Substituted here, we got LHS part is pi. Now let me take the RHS part, curl f dot n ds. So first of all, curl f is what? Del cross f, I j k. Substituted the f1, f2, f3, we will get the k. Now surface integral curl f dot n ds, just now we got del cross f is k, so k dot n ds. Double integration of, actually k dot n is k dot a, where d is with respect to in the xy plane. In the question only he mentioned that in the xy plane. In the xy plane we know that, so ds is dx dy by n dot k. ds is dx dy by n dot k. So n dot k dot en cancel. Double integration of dx dy. Now where r is the projection of as on xy plane. Just now I said that k dot n is equals to dx dy. So n dot k dx is equal to dx dy. Just now I said here, so that's what this one becomes as dx dy. Now RHS part here, this is RHS part, surface integral. What we got here? Double integration of r dx dy. Double integration of r dx dy. So x varies from here. So where y square is equals to 1 minus x square, y is equals to plus or minus under root of. So y is equals to plus or minus under root of. These are the limit points. When to got the x limit points, y equals 0, x square equals 1, and x equals to plus or minus 1. So x varies from minus 1 to 1. So here we can write this one as even function. So this can be written as 2 into integration x equals 0 to 1, 2 into integration of y equals 0 to this one, 2 into 2 4. By simplifying this we will get the pi value. Answer is pi. RHS is pi, and also LHS here we got curl integral f dot r is pi, and this one also pi. Hence the Stokes theorem is verified. So these are the comes under the part of the vector integral theorems. Thank you everyone.